another frame of reference. Well, that brings us to the question of change in position and displacement. You see, no matter where you observe from, if you observe an object in motion, that moving object will change its position. All right? A moving object changes its position, and we're going to call that position x. You see, a motion can be in the x direction, in the y direction, or in the z direction. Now, very often we consider motion in the x direction, so we will represent the position of an object using x. On the other hand, if you consider objects moving in the y direction, then we will replace x by y. That means when you represent the position of an object, x can be replaced by y depending on if it is moving horizontally or vertically. So we will represent the position by x and time with t. The position x changes with time t. The position is a function of time. That means we can now write an equation for the position function, can't we? Now, here we have an object in motion. You can see again an animation which is taken from an open web. Now, an object is in motion. Its position changes with time. You can see as time changes, the position changes. Now, let's take a specific example. The position x of the car changes with time t. Let the position of the car be x1 when the time is t1. Alright, here I'm going to put a car. There is the car. Its position is x1 when the time is t1. And the car is at x2, there you are, when the time is t2. Alright, so you got a car at position x1 when the time is t1. The car is at position x2 when the time is t2. What is the change in position? The change in position is the final position minus the initial position, x2 minus x1. And we will represent that change in position by the notation delta x. I'm sure most of you know this. A change in any quantity is represented by using the letter delta. Delta x is the change in x. Delta y is the change in y. Delta t is the change in time, and so on. So the change in position of the car is x2 minus x1 equal to delta x. Now, this change in position occurred in what time? It occurred in the time t2 minus t1. And now, I want you to watch this statement I made. The change in position of a moving object is called its displacement. You see, the object got displaced from the initial position to its final position. So this delta x, the change in position, is called the displacement of the car. This change in position delta x occurred in a time interval t2 minus t1, and we will represent that by delta t. Alright? Now, delta x divided by delta t is called the average rate of change of position. Delta x divided by delta t is called the average rate of change of position, and we call it the average velocity. In other words, average velocity is the rate of change of displacement with respect to time. You see that? Displacement divided by time is a measure of the average velocity. Well, now let's distinguish between average speed and average velocity. What is the difference between speed and velocity? Let's assume that the car moves from point A to point B along a curved path. This is the car which is originally at point A, and it moves to point B along this curve. I think that has gone out of the screen, but the car is over here at point B along this curve. Alright, the length of the path is the distance covered by the car. Look at that, the car went along this path, and so S is the distance covered by the car. Now the rate at which an object covers a certain distance is called its speed. So speed is the rate of change of distance, the rate at which an object covers a certain distance. In other words, average speed is distance covered divided by time, that is S divided by T. This is S divided by the time taken. What is the unit for measuring average speed? Distance is measured in meter, time is measured in second, it is measured in meter per second. But now tell me, the object, the car moved from A to B. What is the change in position of the car? What is the change in position of the car? The net result is that the car moved from position A to position B, and therefore the displacement of the car is the shortest distance measured from A to B, and it has a direction. Watch this. This is the displacement. It's the shortest distance measured from A to B, whereas the distance traveled is the length of the path taken. Displacement is the shortest distance measured from the initial position to the final position. Now you notice that displacement has a direction from the initial position to the final position. There you are. Displacement delta x is the shortest distance measured from the initial position to the final position, and therefore the average velocity is the rate of change of position. The average velocity will be the rate of change of displacement. It is delta x divided by delta t. Whereas the average speed is the distance covered divided by time. The average velocity is the rate at which the displacement is being done. Delta x divided by delta t. Velocity has a direction. So what is the distinction between speed and velocity? Speed simply tells you the rate at which the distance is being covered, whereas velocity gives you two information. What are the two information? It tells you the rate at which the position of the object changes, and also it tells you in what direction is the position changing. So velocity carries two information with it. So you must distinguish between speed and velocity. Let's now talk about instantaneous velocity. What's the meaning of instantaneous velocity? Velocity at a given instant. Now, in the last slide, we defined average velocity or average speed. In other words, it is the velocity in a certain interval of time. We are now interested in finding the instantaneous velocity. What is the velocity of the object at a given instant of time? Often we need to find the velocity of an object at a given instant. Now, here we have, again, we go back to the same example. The object is displaced from A to B, and the displacement is delta x. Velocity at a point can be obtained by making the time interval shorter and shorter and shorter. You see, we want to find the instantaneous velocity, velocity at a particular instant. So what do? Make that time interval shorter and shorter, and making it very close to zero. It cannot be zero, but make it as close to zero as possible. When delta t is made very small, what happens? The point B will come closer and closer to point A. Look at that. This is the path of the object. This is the path taken by the car. And so the average velocity during that interval is delta x divided by delta t. And now, suppose the car is moved from A to B. You bring B over here, and you notice that the time interval is now shorter. If B is over there, the time interval is even shorter. And if B is over here, let me write down those points there. Suppose this is my point B. What I'm doing is I'm making the time interval shorter and shorter. You see, if this is the initial position and this is the final position, then the average velocity is delta x divided by delta t. On the other hand, if this is the final position, the average velocity for that interval will be, this is my delta x, and delta t is now shorter than before. Now, on the other hand, if this is the final position, this is the new delta x, and delta t is shorter now. If this is the final position, delta t is even shorter. That means I'm now getting my point B is coming closer and closer to point A. And I'm very, very much close to defining instantaneous velocity. So what did I do? I make the time interval shorter and shorter so that my interval becomes smaller and smaller. And finally, what happens? When delta t is made very small, then point B gets very close to point A. And finally, what happens is, when the velocity at point A, when B is very close to A, we can then say the velocity during that very small interval can be called the velocity at A, and that will be defined by the tangent drawn at